Good day again to everybody. So we are now in the last stretch of our discrete math, and this video lecture is actually the second to the last already. And this topic is on relations. But before we proceed with the definition of relations, we need to recall our definition for Cartesian product, which you have encountered in your high school math. Normally, when you have your Cartesian product, you have encountered this when you are dealing with your Cartesian plane. If you get your points on the Cartesian plane, it will always have ordered pairs, right? So for your Cartesian product, so if you now consider two sets A and B, and then the set of all ordered pairs having the first coordinates in A, the second coordinate is coming from B, you get your Cartesian product written as A times B or A cross B. Thus, by definition, your A cross B or A times B is just your ordered pair AB, where A is coming from set A and B is coming from set B. In other words, to get your Cartesian product, you just pair every element of your first set to every element of the second set. So let's have this example. So looking at this example, suppose set A is given by the elements 1, 2, and B is having the set containing A, B, C, then A cross B will now be, so we just get every element of the first set and just pair it to every element of the second set. So 1 is paired to A, B, and C. Then 2 is paired to every element also of the second set. Therefore, our Cartesian product will have 6 elements. Now, if you will consider B cross A, this will now be the other way around. You get every element of set B and pair it to every element of set A. So you have A is paired to 1, A is paired to 2, B is paired to 1, B is paired to 2, C is paired to 1, and then C is paired to 2. So clearly also, from these two examples, it is not always the case that A cross B is equal to B cross A. Okay? So, ibig sabihin, Cartesian product is not commutative. Again, basta sinabing Cartesian product, just get every element of the first set and pair it to every element of the second set. We can extend this definition, the Cartesian product, to three or more sets, or better known as the n-fold product. So, ganun din. So, halimbawa, A cross B cross C, that will be your ABC, where A is an element of A, B is an element of B, and small c is an element of set C. So, you get every element of A, pair it to every element of B and C. Of course, pag mas marami na yung sets involved, mas komplikado rin yung paglista. And then, we have our product rule. If A has m elements and B has n elements, then A cross B is just m times n elements. As we have seen in the first example, set A has 2 elements, set B has 3 elements, then if you get the Cartesian product, it's just 2 times 3, or that's 6. Now we consider the definition of the relation. So a relation on two sets A, B is simply a subset of the Cartesian product. So when you talk about the relation, elements of the relation will always be elements of your Cartesian product. But this time, a relation is specified by an open sentence. Or this open sentence is a condition that you will be satisfying based from your Cartesian product. So for example, uh, in the first set, you can have A is less than B. So that can be the condition. Okay. So if you will, and cannot get the first example, by the way, because the elements are letters and numbers. But anyway, if let's say your set A would involve whole numbers, set B will also involve whole numbers, then if we would like to list down the elements in the relation for this example, we just get A must be less than B. Or you can have the open sentence A plus B is equal to 5. So from your Cartesian product, the ordered pairs that you will only get are the elements wherein when you add A and B together, the sum will be equal to 5. So again, a relation is just a subset of your Cartesian product together with an open sentence or together with a condition. So let's take this example. Let R be a relation, or let R be the relation from set A to set B, where set A we have the elements 1, 2, 3, 4, and set B we have the elements 1, 3, 5, and the relation R is defined by x is less than 1. We need now to find the elements of R. So if we want now to get the elements of our relation R, we get all ordered pairs, but remember your ordered pairs x, y. Your relation is defined as from set A to set B. Therefore, this will come from your set A. This will come from your set B. Your condition is x is less than y. So you just get all ordered pairs such that your x is less than y. So 1 cannot be paired to 1 because they will be equal, but 1 can be paired to 3 because 1 is less than 3. 1 can be paired to 5. What else? 2 cannot be paired to 1, but 2 can be paired to 3. 2 can be paired to 5. What else? 3. So we're here now. 3 cannot be paired to 1. 3 cannot be paired to 3, but 3 can be paired to 5. And then 4 cannot be paired to 1, cannot be paired to 3, but 4 can be paired to 5. Okay? So we now have the elements of R. These are ordered pairs that are subset of the Cartesian product A cross B, but the open sentence that we are considering is that the first element of our ordered pair is less than the second element of our ordered pair. Now, we look at the definition of the domain and the range. So the domain is, so if you look at the binary relation, so binary relation, we're just considering two sets. So the domain, so if you are considering your relation R based from the ordered pair AB, then if you take all the first elements, that will be your domain. If you now consider your second elements, that will be your range. So if we will go back to this example here, the domain of your relation R will now be 1, 2, 3, 4. Where did I get those values? 1, 2, 3, and 4, considering all the first elements. Now, if we want to get the range of R, we just get the second elements, 3 and 5. 3 and 5. So the domain and the range. Now, we also would be looking at the properties of relations. So we have what we call the reflexive property. So a relation R from a set A to itself. So a set A to itself is a reflexive. That is, if we get your element A, apply the open sentence to itself, okay. So a relation from set A to itself is reflexive if A are A for A as an element of A, for all A in A, the ordered pair AA must be an element of R. So what is this property saying? Get an element in your set, apply your relation or the open sentence in that element, the resulting ordered pair must still be in the open sentence or in the relation. And this must be true for all A in your set A. If you don't get, so we now have the irreflexive. For all A, B as an element of A, if you apply the relation R, this implies that A is not equal to B. Then for the symmetric property, this time you get two elements. Okay, you get two elements in your set A, any two elements in your set A. Apply your relation ARB. This must imply that B is related to A as well. In other words, you must get the same result here. Now, for the antisymmetric for all A, B, okay? So for the symmetric, for all A, B as an element of A, if you get A and B, apply the relation, this should imply that, again, this should imply that B is related to A as well, okay? But if you now will be looking at the antisymmetric, for all A, B as an element of A, and you get A, R, B, and B, R, A, this implies that A is equal to B, okay? So, difference nila dito, you get A, R, B, and B, R, A. This should imply that A is equal to B. And then for the transitive property, you get any three elements. This must be all possible combinations, three elements, A related to B and B related to C, then you must get A is related to C as well. Okay. Uh, our main concentration for this list of properties will be the reflexive, the symmetric, and for the transitive. Don't worry, we'll have a few examples in a while for those. So why am I saying that we will be concentrating on those three properties? Because the next definition will now tell us the importance of those properties. And the next definition tells us about equivalence relation. And according to this definition, uh, equivalence relation. So a binary relation R on set A is an equivalence relation if R is reflexive, symmetric, and transitive. So dito na tayo mag-example ng properties natin. Okay, first example, we have R is the relation. R is the relation, okay? And we are considering the set of natural numbers defined by X is related to Y if X plus Y is even. If X plus Y is even. So this is now our open sentence. Therefore, if we will now verify if this is an equivalence relation, we have to test reflexive property. And according to the reflexive property, what do we need to show? What do we need to show here? For all X as an element of the set of natural numbers, okay, X, R, X must be satisfied. Okay, that is, this implies that X plus X must be even. So this is for all natural numbers. So is it automatic that if we get a number, add to itself, natural number, pag sinabi natin na natural number, di ba, these are the positive integers. These are the positive integers. So here, what do we know? We can have x is even. Diba? So if x is even, so a is an element also of our natural numbers para positive. Okay? Kasi nga natural number, hindi pwedeng integers ang ilagay natin sa a kasi pag ginawa natin integer, pwede maging negative. So hindi na siya magiging natural number. Okay, so here, if x is even, we have 2a plus 2a. Okay, so x, rx must be 2a plus 2a, or this is 4a or 2 times 2a, which is even. So okay siya. Now, if x is odd, then a is a natural number. Our x, rx, will now be 2a. Sorry, that should be 1. Bakit b yung nilagay ko? Let me change this. This should be 1. This should be 1. Where's that? Be 1. Therefore, xrx will now be 2a plus 1 plus 2a plus 1. So where did I get 2a plus 1, 2a plus 1? Because xrx is defined by x plus x. The result must be even. And what do we get here? We get here 4a plus 2, or that's 2 times 2a plus 1, which is again even. Therefore, what will be our conclusion? So we can now conclude that, therefore, for this one, therefore, R is reflexive. Okay, R is reflexive. Next, we want to check if it will be symmetric. So symmetric, what do we need to show? So symmetric, for the symmetric property, we have to show that for all xy as an element of the set of natural numbers, x, r, y implies y, r, x. So what do we need to show here? So if we get x and y from the set of natural numbers, x plus y implies y plus x. So ang sinasabi natin dito is, kung gagamitin natin definition, di ba? Pag ginamit natin definition ng R, ano yung sinabi niya sa R? Dapat x plus y is even. And then, y plus x, dapat ang lalabas sa y plus x is also even. Okay, so I guess for this one, we don't really need to go through so much detail here. Since kung ang x na ginamit mo dyan, yan din yung x na gagamitin mo rito sa part na to. Whatever x you use here is the same value of x that you will use here. Whatever value of y you use here, it will be the same value of y that you will use here. Therefore, if x plus y is even, since addition is commutative, if this is even, then this must also be even. Diba? Clear naman na yung part na yun. Kaya, we can conclude here that, therefore, R is symmetric. R is symmetric. Okay? And for the third one, we have to show that it's transitive. We have to show that it's transitive. How do we do that? So for the third part, transitive property, this is now for all x, y, z. We have to show that x related to y. Okay, balik kayo dun sa reflexive. Transitive, I mean. Transitive, so you use and. Okay, so you have x, ry, and y, rz must imply that you have x, r, z. So what do we mean here? What we mean here is by the open sentence, it will be assumed that x, ry, this is x plus y is even. Okay? So similarly, y plus z must be even also. So the question is x plus z even also? Okay? So how do we show that? So when will x plus y be even? Okay, so let's try to look at this one. If x is even, can we pair it to a y that is odd? Okay, so if you will look at in the previous section here, we have seen that an even natural number plus an even natural number will be even. An odd natural number plus an odd natural number will be an even natural number. Okay, going back here. If x is even, we cannot pair it to an odd. Diba? Kasi tingnan nyo ha. If you, let me just give a counter example. If x is even 2, if I pair it with an odd, isn't it that the result is odd? Okay? So it means that if x is even, so tingnan natin yung breakdown. So ibig sabihin dito is, if x is even, y is also even. Okay? Because if x is even, y is odd, the result is odd. That cannot happen. So that should mean that since this is an assumption, it means that for the second, y is even, okay? For this condition, y is even, z is also even, okay? So for this case, so this parang ito yung case 1 natin, so it means for this one, x is even. So this implies that x is even and z is even. Therefore, x plus z is even. Okay? So na-satisfy natin dun sa una lang. Unang case pa lang yan. Ano pa yung case na pwede mangyari? So yung isang case is odd. So for the other case, it should now be odd. So case is x is odd, but we have seen earlier that if x is odd, y is also odd. Hindi pwedeng odd even kasi odd yung lalabas. So dapat even, o kaya odd and odd. So it's true that x is odd, y is odd, x plus y is even. So x is odd, y is odd. So again, x plus y is even. So completuhin, we have here x plus y is even. So dito, y plus z is even. Okay? Next. So y is odd. Since y is odd dito, y must also be odd here. Therefore, z is also odd. So that we get y plus z is even. Okay, so this means that we would like to verify. So anong lalabas? X is odd and z is odd for this, di ba? For this part here. So ano yung sinasabi natin sa cases na to? X is odd, y must be odd para even ito. Since ginamit mong y dito is odd, yun din yung y na gagamitin mo rito. So, para maging even yan, because this is an assumption, z must be odd. Di ba? Kung ano yung ginamit mong x dito, yun din yung gagamitin mong x dito. Kung ano yung ginamit mong z dito, yun din yung gagamitin mong z dito. Okay? So if x is odd, z is odd. Ito na yun. X is odd, z is odd. What can we now say with x plus z? So x plus z is also odd. So after looking at all the possible cases here, we have seen that the relation was satisfied or the transitive property was satisfied. Therefore, therefore, R is transitive. And since all the conditions are satisfied, then final conclusion, thus R is an equivalence. Therefore, R is an equivalence relation. Next example. Let's assume, paki-edit na lang. Let us assume that R is a relation on the set of real numbers defined by, so ito yung pagka-define ng relation. This is now the open sentence. A minus B as an integer. Okay? So, tinitingnan natin yung real numbers. Pero, ang limitation natin dito is that if we take any pair ng real number, dapat A minus B is an integer. A minus B is an integer. So, prove that R is an equivalence relation on the set of integers. So, let's proceed. First, we have the reflexive. So, letter A is the reflexive for all A as an element of the set of real numbers A are A if and only if A minus A is an integer. Okay, so look at this reflexive property. We will consider all elements of our set of real numbers. We have A are A if and only if A minus A is an integer. Okay? So clearly, if you get any real number, diba? If you get any real number, A minus A will always be equal to 0. And isn't it that 0 is an integer? Okay? So, nasatisfy niya. If you get any real number, take that real number minus itself, the result is 0, which is an integer. Therefore, R is reflexive. Next, After showing R is reflexive, the next property that we have to show is ano yan? Reflexive, then symmetric. So for the symmetric property, letter B, for all A, B as an element of the set of real numbers, we have to show that A R B implies B R A. Okay, so this is assumed to be true, diba? So we have A minus B implies B minus A. This is to be an integer, diba? So A minus B must be an integer. Okay, so if this is an integer, so let's say we let A minus B equals X. X is an element of the set of integers. Isn't it that ang gusto nating pakita is B minus A must also be an integer. But what will be B minus A? Isn't it that from algebra, if A minus B is X, then B minus A is just the negative of X. Because, bakit naging negative of X? Explain natin yung part na yun. So, kaya siya naging B minus A is naging negative of X because if A minus B is positive X, okay, then isn't it that if you factor out minus 1 here to get B minus A, so you have A minus B equals X. You factor out minus A, that ay minus 1, that will be minus A plus B. Since you have introduced minus 1 to the left side, you introduce also minus 1 to the right side. You get the negative of B minus A equals minus X. Okay, is that clear? So we base it from the first one. We have A minus B is equal to X. Therefore, clear ba yun? Okay, if you want, another way of, sige, alisin natin. Hindi confusing. So another way, let me rephrase that. Let me change that. Another way that you can look at this is maybe you can just get a value. If A minus B is X, let's say you get A is 5, let's say you get X, B is 2, then you have 5 minus 2 is 3. So if you invert, you have 5 minus A, that will be, or if you interchange the value of B and A, that will be negative X. So clearly, minus X is also an integer. So if X is an integer, then if you just get the negative of that integer, it would still be an integer. So pasok naman siya dun sa qualification. Diba? Kasi parang sinasabi nilang doon, para maging, para masatisfy niyo yung property na yun, you have ARB implies BRA. So this is an integer. Papakita mo lang that B minus A is an integer. Hindi naman sinasabi ron na dapat equal sila. Ang sinasabi ron, if this is satisfied, this must also be satisfied based from the open sentence. And ano yung open sentence? Yung ARB integer. Dapat pag kinuha mo si BRA, integer din yung lalabas. And this is an integer, therefore, we can now conclude here that R is symmetric. Symmetric yan na. Is symmetric. And finally, transitive property type. So for the transitive property, for all a B, C as an element of the set of real numbers, A are B and B are C, implies A are C. So this is, remember, this is an if-then statement. So you assume this to be true. So if you will assume this to be true, since this is an end, so this must be an integer. This must also be an integer. What do we have to show? ARC must also be an integer. So that is what we want to show, that ARC is an integer. So A minus B is an integer. B minus C is an integer. So question now is A minus C an integer also? Okay. So by closure property, that should only tell us that the A minus B is an integer and B minus C is also an integer. Okay. So that should tell us that A must be an integer, C must also be an integer, thus A minus C is also an integer. Okay, so you now have the transitive property also for this one. Again, paano naging transitive property yon? For A minus B, okay, so ano nangyari doon? A minus B is an integer. So para nag-closure property lang tayo doon. A minus B is an integer. B minus C is also an integer. Therefore, it should tell us that A minus C is also an integer. Okay? So there you have it for our section on relations. So gusto niyo i-conclude dito, therefore, R is an equivalence relation. So there will be one last lecture which will be on functions.